Okay guys, got myself a 2001 Nissan Maxima. Check engine lights on. It runs great, drives great, all that stuff is fine. In 2000 and 2001, Nissan Maximas had a lot of problems with coils, ignition coils. They fail or the resistance value becomes improper, so the ECU detects a trouble code. I have connected my ISO 9141 language scanner to my OBD2 port, and I've got a P1320. In this screen it says it's stored. That means it happened the last time it was running, and it is also 1322 pending, so it's happening right now for ignition signal primary. That means that the engine computer detects a problem with the waveform coming back from one of the ignition coils. There's 6 of them, and I need to figure out which one it is because they don't have a specific code for a coil that's sending back an improper waveform but not causing a misfire. So let's get this figured out as quickly and accurately as possible. Okay, transverse engine. There are 3 coils underneath this cover. These are the even numbered coils: cylinder 2, cylinder 4, cylinder 6. On the back side we've got 3 coils. This one is cylinder 1, cylinder 3, and cylinder 5. Okay, on each ignition coil there are 3 wires going to the ignition coil. There's a red one on the left. That's 12 volts positive anytime the key is in run position. There's a little winding of wire inside that coil called a primary winding, which comes out in the middle terminal, which is a black wire, I believe, on all the coils. And the way ignition coils work is the coils are charging most of the time, meaning there's 12 volts positive to the left pin and the negative or ground to the middle pin. And anytime you break the connection in that coil, because the ferrous metal part of that's inside the winding can't move in an ignition coil, like it can move in a relay or it can move in a trunk actuator. So on those kind of devices, when you have the coil energized, it either holds a switch closed or open, or it holds a metal rod, pulled so that it can pop a trunk, or it can, disconnect or connect the connection inside a relay. But in an ignition coil, the ferrous part can't move, so when the negative wire gets disconnected, the energy has to go somewhere. So in this case, it goes down to a spark plug in the form of a high voltage charge and jumps the gap between the electrodes on the spark plug and lights off the fuel mixture in the cylinder. So we know what the red and the black wire do on these coils. Now there's a third wire. It's on the right hand side. On this coil, it's a blue wire with a red stripe. So there's one of those wires in a different color combination on each of these 6 coils. They go back to the ECU and they report to the ECU a waveform generated by the operation of the coil. And the ECU monitors that waveform to determine if all the coils are working right. So back at the ECU, and those wires are the same colors at the coils as they are at the ECU. They go to these pins on this yellow connector. It's hard to see, you need a flashlight. Okay, the yellow connector on the bottom row, they are the first 3 wires from the left. There's gray, and there's purple white, and there's gray red. And the next row up, there's an open terminal. It's not used, but the 3 wires from the left to the right of that are the other 3 wires for the coils. So I'll tell you the color combinations. So your yellow red goes to cylinder 1's coil, green red goes to cylinder 2's coil, blue red goes to cylinder 3's coil, which remember we just looked at in the video is the middle coil on the back row of cylinders. The gray wire goes to cylinder 4, purple white goes to number 5, and gray red goes to number 6. Okay. So we need to figure out which one or more of our coils are malfunctioning. And since most people do not have an oscilloscope to view the waveform coming back from the coils, we have to use a multimeter because it's cheaper and most of us have one. Now a multimeter can't see waveform, for itself, but a multimeter can see the average voltage that generates a waveform. So at idle, this Nissan's going to generate a waveform that's moving along slow enough that most multimeters are going to bounce around in their reading, having trouble trying to average it out. But if we rev the engine up past about 2500, it's faster than the refresh on most multimeters, you get an average voltage reading at those wires back at the ECU. So I'm going to take a broken piece of the bail off of my ECU connector, and I'm going to jam it in the throttle to rev her up about 2500 or 3000. Oh, and the first time you do it, the computer might make a mistake. Try to limit the RPM, but keep doing it. The computer lets you have the RPM you want. It's been particularly stubborn. I don't really have to care for this. We got 4,000 RPM. I guarantee my multimeter can't keep up with that waveform and try to refresh the screen every time it pulses back and forth. So this should tell us which of these damn coils is broken. My multimeter is auto ranging, but if you've got a Sunin or old Sunin or one of those Harbor Freight Chinese copies of a Sunin, something like that, you'll have to select a DC voltage range with tens digits or hundreds digits. I think they give you a choice of 20 volts DC or 200 volts DC. Either one will work for this test, but mine's auto ranging, so I'm just going to pay attention where the decimal point is. Okay, so I need a flashlight because you guys can't see. So I have selected for my negative one of the ground wires on the ECU, which is usually black wires on a Nissan, and they're usually at the far end of a connector. There's two of them over at the end of this green connector. There's two more ground wires over here on this gray connector, but I picked that one because it's out of my way and I won't bump it while I do this test. So I'm going to test these coils, starting with the gray. What is it? Hard to see. I'm going to start with the gray wire. Okay. Looks like my ground came loose. Okay. So I've got 0.23 on the gray wire. That's acceptable. On the purple-white wire, I've got 0.2276, whatever. That's acceptable. And on the gray-red wire, I have 0.233, that's acceptable. I'm going to move up to the next row of wires for my other three coils. I got to clear these wires out of the way. Okay, so we're going to start with the, oh gosh, the yellow wire with the red stripe. My ground lead fell out. Might pick a better, okay. So that one's got 0.21, that is acceptable. I'm going to move on to the green wire with the red stripe. And we got 0.32. Now the computer's looking for voltages of over 0.3 at this kind of RPM or the waveform that generates that voltage as a problem. So this is probably my bad coil. But we'll check the next one just in case. That's our blue wire with the red stripe. Okay, we're going to probe that. Blue wire with the red stripe gets us a 0.21. So the problem we're having is whatever coil is on our green wire with the red stripe, that most likely is the issue. But I'm going to turn this singing thing down. All right. So I'm gonna report back hopefully on this YouTube video once I replace the it looks like coil number blue wire. Let's see what wire I was on. Okay, the one that I had a problem with was, I believe, the green wire with the red stripe. So that's my number 2 coil is defective, most likely. It has an improper, most likely an improper resistance through the primary winding in the coil. So I'm gonna either obtain a used coil or a new coil and replace that one, and hopefully make another video hopefully fixing this check engine light. Thanks. Bye.